Hi, this is Tavi Greiner, Astronomy.FM's Vice President of Communications. If you enjoy our programming, please let us know with a donation to Astronomy.FM/donate. We really do rely on your support, and it's true, every little bit counts.
AFM.
The sun is yellow, Sirius is blue, and good grief, the sky is too. I like listening to the voice of the universe, Astronomy.FM radio.
Hello and welcome to another edition of Comet Watch. Hello and welcome to the slightly snowy April edition of Comet Watch. My name is Evetts, and yes, I am in upstate New York currently, and this morning it was snowing. This is April and it's snowing. Oh boy. So, as usual, I'm joined by my sidekick,
which is Neil Norman, in England, where it's raining and cloudy.
Unfortunately, Mary is not well, so she can't join us this month, but get well soon, Mary, as we miss you. We will start off, as always, with the latest discoveries, the shipping forecast, as they call it. Just want to thank Nick James, as always, for the use of the Comet section visual observations page, and thank you to Jonathan Shanklin for his hard work in maintaining it. So, we'll kick off with March the 4th, discovery of A2017 U7 reported.
And again on March the 4th, was the discovery of A2018 C2 reported.
March the 9th, Warachart Boomplod reports a Kreutz Comet in real-time C2 images.
The 12th of March was Simon Liu reports a Kreutz Comet in real-time C2 images.
March the 13th, Warachart Boomplod reports a Kreutz Comet in real-time C3 images.
On the 14th of March, Warachart Boomplod reported a Kreutz Comet in real-time C3 images.
Again on March the 14th, Warachart Boomplod reports a Kreutz Comet in real-time C3 images.
On March the 16th was the discovery of 2018 E1 Atlas reported.
Again on March the 16th, discovery of 2018 E2 Barros reported.
On March the 17th, Warachart Boomplod reports a Maya group comet in real-time C3 images.
March the 19th, discovery of 2018 F1 Grua.
On March the 20th, Zhejiang Zhu reports a Kreutz group comet in real-time C3 images.
March the 21st, recovery of 2005 JN P/Spacewatch as 2018 F2 reported.
On March the 28th, the classification of 2018 C2 was changed to Comet.
Again on March the 28th, discovery of 2018 F3 Johnson reported.
Again on March the 28th was the discovery of A/2018 F4 reported.
March the 30th, Warachart Boomplod reports a Kreutz Group Comet in real-time C3 images.
On the 31st of March, Warachart Boomplod reports a Kreutz Group Comet in real-time C2 images.
And on April the 2nd, the visual observation page was updated. Now, as always, if there's no recent updates, you can always try the German Comet Group page, or Yasuichi Yoshida's page for information, or Liga Iberoamericana de Astronomía for observations. So, we'll move into current comet magnitudes, April the 2nd, and observable region, April the 2nd. So, Pan-STARRS 2016 M1 is magnitude 10.5. It's a bright comet, observable 55 degrees north to 70 degrees south. It's a morning object. The last visual observation was 2018 March.
Next up is another Pan-STARRS object, 2016 R2, magnitude 12, but it's now fading. 70 degrees north to 10 degrees south, best viewed in the evening, and last reported in March.
Pan-STARRS 2016 N6, magnitude 12, steady, 70 degrees north to 10 degrees north all night, last observed March 2018.
Next is 240p NEAT, magnitude 13 question mark, because it's steady, currently at poor elongation and is yet to be observed.
And of course my favourite, as always, 29p Schwachmann-Wachmann, 13 magnitude question mark. It varies. Poor elongation. The last visual observation was October 2017.
Next we have Heinz 2017 T1, magnitude 13 and fading. 10 degrees south to 35 degrees south, early morning, last seen in February, but a note of caution, it's probably disintegrated.
Yes, I was going to say I'd heard about that, but to say that is still open to question. And please submit pictures and any observations on this if you can. Next is 185p Pettirou, 13th magnitude, fading, 45 degrees north to 30 degrees south. It's an early evening object, last observed March 2018.
Next is old favourite Pan-STARRS 2015-01, magnitude 13 and fading, 70 degrees north to 10 degrees south, all-night object, last reported in March.
Johnson 2015 V2, 13.5, fading, 70 degrees south to 75 degrees south, so this is now a southern hemisphere object, and it's an early morning object, and last visually observed from the UK in 2017 September.
And lastly, we have 48p Johnson, magnitude 14 question mark and brightening, 25 degrees north to 65 degrees south, visible in the morning, and it says not yet observed here, but I've seen a confirmation picture of it today, so it has been picked up as of April.
So that's as an image, but is that not as a visual observation?
As an image, not a visual observation, yes.
Okay. Well, as always, the observable region is an approximate indication of the latitude at which the comet may be seen. Obviously, under good conditions, comets may be visible outside this range. The period when visible is for the UK, and if the comet is visible from the UK, otherwise for 40 degrees south, or the equator as appropriate. And of course, the last visual observation is as received by the section. Details are often updated on the basis of observations published elsewhere. And of course, details are normally fully updated at the beginning of each month. However, may be updated more frequently for comets brighter than 10th magnitude. The date of the most recent partial update, which may be applied to only to one object, is given. And I do stress, beginners will often find comets fainter than about 7th magnitude difficult to locate. There are position and finder charts available from the BAA online. You can also go to the livesky.com for a lot of information. They have an excellent planetarium program, and of course you can always use Stellarium, Starry Nights, or the Sky as well to find these objects. And to be honest, if you're using a go-to telescope, my suggestion is always link your computer to your telescope and let your planetarium program put you spot on, assuming of course you've done your polar alignment correct. And any other comments, Neil, before we go to the next part of the show?
No, that's summed up beautifully.
Excellent. Oh, one other thing. Project Orcock. As far as I am aware, the pages are now down, unless of course Roger Dimmock has actually agreed to have them transferred to somebody else's website for posterity. That at the moment is something I will look into, and I will report back on perhaps next month's show. Well, we have a special guest this month. Would Her Majesty like to introduce herself?
Oh, good Lord, no. You can't introduce me like that. Try again.
Would our special guest like to introduce herself?
Oh, hey, it's great to be here. So I'm Dr. Michelle Thaller. I'm an astronomer at NASA. Definitely not royalty, so there you go.
Oh, well.
Great to be here, though. So yeah, I work at NASA headquarters. I'm an astronomer by training, sort of just straight out astrophysicist. But I've been working as the science communication person for the Science Mission Directorate. We run about 108 science missions at NASA, and a lot of them are to comets or to sort of these primitive bodies like asteroids in the solar system. So even though I'm an astronomer, I'm catching up on all my comet stuff. And it was wonderful to hear about all the different comets that are observable right now. That was really exciting.
I think we're actually quite lucky in the fact that we do have a lot more dark sky areas, which will help new people coming into the hobby. I say it's a hobby. I describe myself as an amateur astronomer intermediate. I'm nowhere in the league of Patrick Moore, and certainly not Henry Hatfield. They are gods to me as far as I'm concerned. They can sit down, they can just toss off information at the drop of a hat about anything with that, and as far as I know, they've never resorted to notes. I think the only time I'll say Patrick did that was he gave a lecture on how to measure the height of a lunar peak in a crater, and I believe he had notes for that and a very nice presentation, which was of course immediately challenged by Commander Henry Hatfield, Royal Navy retired. But
that's one of the best ways to get students to actually enjoy trigonometry, because when you know the length of a shadow, you can measure that. You can measure the angle that you are in the sunlight and all of that. Then you can calculate how high mountains are on the moon, and they're surprisingly high. Yeah. That's one of the most fun labs to do with introductory astronomy students.
Now, Michelle, could you tell us something about some of the ongoing cometary and asteroid missions that are being handled by NASA at the moment?
Well, absolutely. So, I mean, there's a huge interest in studying comets and asteroids because, as you know, but I think a lot of people don't realize how scientifically interesting they are. They're sort of time capsules. Billions of years ago, there were these smaller bodies that got made into our planets. And, of course, once you get made into a planet, everything gets processed. It gets melted down. It gets differentiated. All the heavier stuff sinks to the bottom. Of course, if you're on the surface of the Earth, you've got rain and wind and erosion. So, pretty much the initial conditions of the early solar system they've been very well erased on large bodies like planets. But then there were these little bits that never got put into a larger planet, just sort of by good or bad luck on their part, depending on how you look at it. And they're relics. They really show you what the conditions, the chemistry, the composition of the solar system was at the time that the planets were forming. And of course, these are the things we know of as asteroids and comets today. And so they're tremendously interesting to us scientifically because they show us where we came from billions of years ago. The organics are interestingly different from Earth, but also very much the same. One of the big questions is, where did the Earth's water come from? Because the Earth seems to have formed close enough to the sun that most of the lighter material, things like water vapor, methane, all the stuff that's sort of light gets blown out into the outer solar system. And that's why the planets out there are much bigger. There's a lot more stuff to build planets out. When you get out to Jupiter and Saturn, that's about where all the water would have condensed, all the methane ices would have condensed. So while there might have been some water on the Earth originally, there probably wasn't as much as we find today. I mean, we think a lot of it was brought in by subsequent comets and asteroids hitting the Earth. And not just the water, but actually the organics in your body. The carbon-based chemistry that makes us life, we think was likely brought to Earth on comets and asteroids. So they're tremendously scientifically interesting.
Now, as I remember, there was quite a debate at the beginning of astronomy about where the planets actually formed, because the modern theory today is, of course, that the gas giants formed closer in and the rockier planets were formed further out. The solar system was perturbed and there was a switch. Now, which of course would have disturbed the Oort cloud, and in some respects, this is probably why we have the asteroid belt in a conveniently accessible place that it is for us today.
Well, that's right. There's a hypothesis that seems to be really growing in terms of evidence called the grand tack hypothesis. And the word tack comes from the sailing term, to tack against the wind. If you want to move against the wind in a sailboat, luckily for us, in a sailboat, you don't have to go just one direction. Even if the wind is blowing you in a way that you don't want to go, you can use these wonderful mathematical vectors, another use of math, to actually direct yourself against the wind. And so the idea that you're talking about is, we're not exactly sure where Jupiter formed. Jupiter in specific is sort of the focus of this. And we think it actually did form fairly farther out in the solar system. We don't think it formed right up close to the sun. But then it seems to have moved in. And the reason it moved in was that when Jupiter was forming, there was still a very thick disk of gas and dust swirling around the sun, stuff that hadn't formed into planets yet. And as Jupiter moved through it, that basically created a drag on Jupiter. Jupiter was sort of moving around in this denser disk, and that made it lose angular momentum, lose velocity. And so it actually moved in toward the sun, maybe as far in as where Mars is now. And then the idea of how did it get back out again? How did it actually move out of the gravity of the sun? Well, that's where the tacking comes in. And the idea is that when other planets started to form in the outer solar system, planets like Saturn and Uranus and Neptune, they basically tugged on Jupiter little by little, something we call an orbital resonance. Every time Jupiter got a little closer to them, they tug it out a little more. And it actually tacked Jupiter against the gravity of the sun and brought it back out. Now, as something the size of a young Jupiter was moving through the solar system, you better believe it disrupted all kinds of things. So, like you said, the gravity may have disrupted the Oort cloud. It may have sent huge amounts of comets and asteroids into the inner solar system. We call this the era of the bombardment, the huge bombardment. If you look at the surface of the moon and how it's craters on top of craters on top of craters, there was a time when there was a lot of stuff coming down from the sky. And like you said, as Jupiter sort of stabilized into this area, it sort of locked these asteroids into this nice, this nice sort of orbiting area between Mars and Jupiter. But of course, I mean, as Jupiter was moving through that area, it would have thrown all that out. So, I mean, a lot of people think that there was more material in the asteroid belt to begin with. But then when Jupiter was moving around, that all got thrown hither and thither all over the place, too. So early solar systems turn out to be really kind of violent, dramatic places. And this is not just a theory. We have telescopes today that are observing young solar systems around hundreds of different stars. And in some cases, we actually see the evidence of planets colliding and huge disruptions. And we see Jupiter-sized planets that have fallen in very close to their stars. So there's actually a lot of evidence from other solar systems in the sky that this really does happen.
So basically, the late heavy bombardment was about 4.1 to 3.8 billion years ago.
That's
the
right.
Neo-Hadron and Eoa-Akron eras on Earth. So Earth was probably a very young planet, probably mostly molten material still when that happened. However, we do know that the moon at that point was there. So again, this is bringing in the theory about Thayer hitting the Earth and the moon being created from the collision. So a lot of stuff coming into play here. And of course, comets were part of that bombardment as well.
Absolutely. And so, one of the reasons, we study comets, and in fact, where we have plans, was it about a year and a half ago, the European mission Rosetta with the Philae lander, went out to the Comet 67P. You guys are probably better at this than I am. Chiramirov Gerasimenko.
Oh, I call it Chirimiri.
That's right, yeah. So we call it 67P, which is a lot easier to say. But it did manage to sample the ice of that comet a little bit. Unfortunately, the lander was not able to operate as long as we'd like. But one of the big plans that NASA has going forward is to return to a comet. We have a mission that's going out to an asteroid right now. It's called OSIRIS-REx, and it will arrive at the asteroid Bennu in July, actually, this coming July. And OSIRIS-REx's goal is to actually take a sample of the pristine material on that asteroid, probably billions of years old, and return that sample to Earth. And then we are hoping to have a similar mission. Now, this mission hasn't been approved yet, but it's been proposed, and we're now sort of developing the proposal. So it's not a done deal yet, but one of the missions that was selected to have a serious look at whether we could do it was something called the CAESAR mission, which stands for the Comet Astrobiology Exploration Sample Return Mission. And that's similar to OSIRIS-REx. It's going to go out, in fact, to Comet 67GP, the one that we were just talking about, 67P. And actually return material from that comet, because there's some suggestion that the water in the oceans, and actually, in fact, the water in our body, has a closer chemical match to water that we find in asteroids as opposed to comets. And so it's kind of an interesting thing. Where did the water come from? I mean, I'm sure it came from both sources, and there was probably some water here originally, but it's kind of a fun journey to figure out where the majority of Earth's water came from.
I think it was 5 years ago. I was at a British Astronomical Association Minor Planets section meeting at Milton Keynes. One of the presenters there actually gave us a heads up on OSIRIS-REx as it stood at that point. And just the whole thought of going to an asteroid, bringing back a sample and physically analysing it in a lab on Earth was like brilliant, because if we could have done that with 67P, I think it would have perhaps pushed comet science even further than the Rosetta mission did. Rosetta basically made all the books that have been on the market about comets obsolete. I think that did about 3 months. Every
Yes.
book you bought about comets, basically, it's just our fun read, because nothing's quite as we thought in the first place. But I think the nice thing about this is it takes away the fear element that people have had throughout the history with comets, as always being harbingers of doom and gloom to planet Earth. Now we know them to be icy snowballs in some cases, perhaps even the building blocks of life as we know it. I won't do my William Shatner impersonation, it's terrible. So the Forrest Kelly one's even worse.
No, I mean, at NASA, I think scientists all over the world, I mean, we think it's a bit unfortunate. The first thing that people think about when they think about comets and asteroids is that they're dangerous, because as you were saying, if we hadn't had these impacts, and a lot of them, and yes, I mean, those impacts were very violent and dramatic, but I mean, you're sitting here as sort of the cruddy stuff that arrived on a comet or an asteroid. I mean, that's where your actual body that you're living in right now most likely came from. So there, we wouldn't be sitting here talking about it if these things hadn't hit that molten ball of rock that was the Earth. I mean, NASA does have a department of planetary defense, and in that way, the OSIRIS-REx mission, while the science return is going to be wonderful, returning the sample of our protobiology, where we may have came from. Certainly, one of the goals is to learn how to better divert asteroids if they ever are a risk to us. And one of the things that we don't understand very well yet is how to predict long-term the path of asteroids and comets. Yeah. Because they change, because there are jets that come off, jets of gas that come off of comets that change the path. Asteroids have something called the Yarkovsky effect, where just the sun heating up one side of the asteroid creates almost like a really, really weak little jet engine. That radiation coming away from that hot side of the asteroid will actually change the path. So, we actually can't predict the exact paths of asteroids hundreds and hundreds of years in the future. We're very good at it. We don't know of anything very dangerous coming in the next, say, 200 years. But then it becomes a problem that we're not that great at really knowing how these things change their orbits. And so we need to find that out.
I think the other thing is, I'm going to shut up in a minute anyway and let Neil get in. I think the other thing is, of course, we don't know how many of these asteroids are solid or just piles of gravitationally bound rubble.
Exactly. And the thing about, people talk about sort of the Hollywood solution of going out with a big nuclear bomb and putting it on the asteroid and blowing it to pieces. And as you mentioned, a lot of asteroids are sort of floating junkyards. They're not really solid things. They're all kinds of little bits of rubble held together by gravity. And in that case, if you sent a nuclear bomb out there, basically all you would do is add heat. So, I mean, basically all you do is you make it mad. That's all you do. Yeah. And you probably wouldn't divert the asteroid very much at all. We have a mission, actually, that we're developing right now called DART. And DART stands for the Double Asteroid Redirection Test. And we're actually going to fly a probe out to this asteroid that has a moon. The asteroid itself, I think, is about 100 meters across. It's called Didymos. And it has a small moon that's about 150 meters across. And that's more the size of asteroid that's kind of risky to us because those are harder to see in our telescopes. Something big, something kilometers across, we probably know is out there because we can see it. But these 150 meter size ones sometimes surprise us. And so we're going to send an impactor out there to smash into this smaller moon and see how much it diverts and practice diverting this moon around this asteroid. So the DART mission will be a lot of fun. It's a chance to smack into an asteroid.
Oh, yes. I remember Deep Impact. And we had a lot of fun with that because a lot of people got really wound up. Oh, you shouldn't be doing this to comets. We won't mention a certain party who got really on their high horse about it because we have a lot of respect for that person as well because of the work he does for Asteroid Day. But as I say, it's really a situation where Jupiter is either benign or malign or malignant towards us.
Yeah.
And the answer is both, right? I mean, so to some extent, yes, Jupiter seems really good at gravitationally attracting comets. And some people say that protects the inner solar system. The first thing you see as you're falling into the solar system is the gravity of Jupiter. Jupiter scoops up all that stuff. But the other side of it is Jupiter also slingshots stuff around and so it throws things into the inner solar system. And honestly, once again, yin and yang, right hand, left hand, it both happen. I mean, it's just, no easy answers there.
I think Neil would agree with me that I think the big wake-up call for us was Shoemaker Levy 9.
Oh, God. I mean, if that had hit here, we wouldn't be talking about it.
Exactly.
No.
But
and of course, Jupiter did throw a comet at us, didn't it? It threw Comet Lexel at us, which very nearly hit us in 1770. So,
that's
and then
cool.
it threw it back out.
I didn't actually know about that one. That's neat.
Yeah.
So what was the story of that one? So we know that there was a comet whose path took it close to Jupiter, and then it came in towards Earth because of that.
Yeah. What happened was Comet Lexel was discovered. It's named after the person who worked out its orbit. On the 14th of June, 1770, Charles Messier picked up a comet very close to Earth. It passed at 0.012 astronomical units away from us, which is just over 1 million miles. And it turns out that Jupiter had thrown it into the inner solar system, and it very nearly hit us. On its way back out, because it was on a 6-year period, Jupiter then threw it out to the solar system completely. So we nearly got hit a good one by that one.
Yeah.
And of course, the interesting thing is, if you look at certain of Jupiter's satellites, the crater chains show the past Shoemaker-Levy 9s.
Oh yeah.
That have come very, very close. I believe that actually someone said that there was possibly a lunar chain that could have been very reminiscent of such a inbound impactor as well, that had fractured and then instead of hitting us, it hit the moon, and it had been a series of individual chunks that hit certain ways. It's basically, you need to be looking at the angle of the craters. So I think I remember Gene Shoemaker saying about that during the whole Shoemaker-Levy 9 thing, that the angle of impact could be worked out by looking at how the crater is actually showing on the surface.
Oh, absolutely. You look and see whether there's any differences in the ejecta blanket, all the stuff that's thrown out. Does it go farther on one side than another? What do the crater walls show you? And I've seen pictures of what you're talking about, these crater chains on the moon, where it looks like something broke up into pieces, then just slammed, bam, 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 and then this straight line down the surface of the moon. And I believe we see those on Callisto as well, the large moon of Jupiter.
The other good thing is that gave Spacewatch the funding it needed, not only just to look at near-Earth objects. They were seeing comets as well. So they were at Spacewatch with Neo Shield. Suddenly, it was very easy, and there was a desire to want to look for these objects. We could task Goldstone, we could task Arecibo now to look at these things and radar map them. I believe our friends Guy and Daniel were using information to image a near-Earth object that was then also, I want to say DL288 or something, because Arecibo and Goldstone then radar imaged it as well. So it's made, I think, not only the amateur community, but the political community aware of what really is out there and we don't always know about.
Absolutely. And in fact, NASA has a directive from the United States Congress. And the first directive was, they wanted us to find, pretty much like 90% of the asteroids, almost all of them. You can never find every single one, but they want us to really know 90%, where the ones that are about 400 or 500 meters across. And that I think we've done with our sky surveys. But now they've upped the ante and said, well, now we want the ones that are more 100 meters across. And to do that, we're going to need more facilities, more telescopes, larger telescopes. And, recently the budget for the Planetary Defense Office at NASA was increased. So there's a lot of work to be done to find these asteroids.
And I think this is probably a very good point to point out. I know that Neil and I do a lot on other places. All this thing about impacting comets or asteroids that are going to hit the Earth being hushed up by the space agencies, it's a load of codswallop. Because there's too many amateur astronomers out there with professional grade instruments.
I love the idea that somehow the sky is off limits to everybody except, say, the U.S. government. I just think this is hilarious. It's like, how could we cover that up? And like you said, I mean, the other thing that we make extensive use of in so many places at NASA is something called citizen science. We get so much data now. I mean, terabytes and terabytes and terabytes a day of data about what's going on in the sky. And yes, we have algorithms. We have AI algorithms that go through and try to identify the changes in light that would indicate an asteroid or an exploding star or a planet around another star, many things. But in some cases, the data does not fit our AI algorithms. And even before we look at it at NASA, we actually port it out to people who volunteer to go through this data. And it's done in very kind of amusing ways. It's almost like playing video games. The graphics are very nice. But we have citizen science programs, for example, to help us discover planets around other stars or even comets that are getting close to the sun. And, we really, people in the public see our data before we do.
Yeah.
So instead of hiding anything, like for example, the very dramatic star that became known as Tabby's star, which was a star that seemed to have bizarre variations, dropping in brightness by a factor of 25%, which we've never seen before. That was actually discovered by a member of the public. And it was from the Kepler mission. Kepler is a NASA mission to discover planets around other stars. But that particular variation was so bizarre, our algorithms threw it out as trash. But it turns out it was real, and it took a member of the public to discover that.
I can't speak for Neil, but I know that my computer is tasked with citizen science on a daily basis.
Yay. Excellent. We thank you. NASA thanks you.
Well, I'm involved with an Australian program called POGS, P-O-G-S, and I think let me pull up. So I've got my Bionic running at the moment. It just sits there and runs in the background.
Yeah.
And it's
so there's citizen science programs that are like that, where basically we just need your processing capability, and then there are ones where we actually need you to click with your mouse on things
Galaxy
that look odd
Zoom.
in data. Yeah.
So yeah, I'm doing Milky Way at home at the moment, and I'm doing POGS, which is basically Milky Way's processing discrete chunks of information, reporting it back. And so is the same with POGS. POGS is a galaxy project. I think, as I remember, Milky Way was an astrophysics project. But as I said, I've got 4 cores. I've got a GPU. I've got a very good GPU on my video card. So between that, they've got about half of my computing power tied up. I don't care. It's nice. You get your name on scientific papers when the people at NASA, ESA, whatever, come to write their papers about using the information that you process through citizen science. You are named on the paper.
Well, absolutely. I mean, that's because you really are a serious part of the research. And when you think about how basic some of this is now to NASA missions, if you've been enjoying the spectacular images of Jupiter that the Juno spacecraft is putting out, I mean, they are, a new batch came out the last couple of days, and they are blowing my mind how beautiful these are. They were all created by members of the public. The Juno team didn't actually have any funding in the original mission to create these images. And so all of the beautiful images you're seeing from Jupiter right now are created by the public and sent back to NASA.
As I say, I'm downloading some of the Juno stuff myself. So I'm getting back into imaging. I've gone to the dark side because we have CCDs and drinking chocolate. I have a really funny graphic. I have Darth Vader standing over Luke, and it says, "Welcome to the dark side. We have CCDs and hot drinking chocolate." But
Darth Vader.
I was about to say Darth Vader, I think, but
I was going to say, pronunciation, dear boy, pronunciation.
Oh, you mean like Beetlejuice and Betelgeuse?
Betelgeuse.
Enceladus and Enceladus, that one gets me sometimes. Yeah, that's right.
Yeah, that's tricky.
Sirius, Osirius.
What about a tricky one? Oumuamua. Michelle, what do you think about that object?
Yeah, that's right. So I gave a talk on that at the American Geophysical Union. I had to practice that a couple times. I mean, that remains just a spectacularly wonderful thing. I mean, that just makes me smile every time I hear about it. So, I mean, in that case, that was the first asteroid you could prove was from a different solar system. And, we suspect that these things come through about once a year, but that was the first one we'd actually found. And it was like nothing else we'd ever seen asteroid-wise. It seemed to be, it seemed to be cigar-shaped, which isn't the way the asteroids are in our solar system. And it was moving just way too damn fast. I mean, that thing just came into the solar system so fast and left so fast that, it does not come from our star. It is not gravitationally bound to the sun. Off it goes.
I love the speculation everybody's going on about Larry Niven's ring world. Is this a ring world? Being sent on a trip through our solar system. I thought that was hilarious.
Well, did you remember Rendezvous with Rama? I mean, that was the one.
Yes.
So at NASA, that was the big one. The people at NASA were sort of calling this Rama because the same thing that in that science fiction story by Arthur Clarke, there's this thing coming through our solar system so fast and it's not going to stop. And we only have 3 days, I think, in the story to get out there and learn everything we can about. Well, in this case, it's artificial. It's from a civilization. But, this was a similar object. It came in and left so fast that, there was barely time to say hello.
I think this is one of the times you make the comment, well, why didn't the dinosaurs survive? They didn't have a space program. I saw that graphic many years ago, and I think it's still true today. With the near-Earth objects, with comets that come in close to the Earth and become Earth grazers, never mind sun grazers, the greatest asset we have is the fact we have multiple nations with space programs. And I'm just looking forward to getting back into for SLS and Orion to get into operation. And I think we can get some spectacular science from comets and asteroids. We can actually go there physically. Humans can. I don't think you can beat the Mark 1 eyeball at the end of the day.
Yeah, well, I would love to see that. I mean, of course, we're very excited about that. I mean, just from a completely selfish point of view, I want to see one of those rockets go up. I mean,
Yeah.
I never saw any Saturn V rockets. I'm too young for that. And I really, by the time the shuttle was running, I was sort of a graduate student. I didn't have a lot of money to go down and see it. I should have, in retrospect, gone to see a shuttle launch, but I've never seen a really big launch. And the SLS will be the largest rocket ever launched, and that's going to be spectacular.
And I think the nice thing is we have people like Elon Musk and Steve Bezos who are.
I want to see a Falcon Heavy too. I totally want to see a Falcon Heavy.
I want to see his big freaking rocket go off.
Even the regular Falcons. So I've seen I think 3 Falcon launch and landings now. And they were so brilliant. I mean, my husband is very busy. He's a NASA engineer, and he's not really a rocket person. He's more of an instrumentation person. But I came back from the SpaceX launch, and when you see that first stage come down for a landing, something in your brain just doesn't compute. I mean, it's like seeing something in front of your eyes that your brain is saying no. That's not happening, because this 10-story building comes down so fast, and just before it lands, and you can see this from the VIP viewing area at NASA at Kennedy. You can see it land on this pad, and just as it lands and stabilizes, that's when you hear the sonic boom. So you see it land, you see it touch down and stabilize, and then you hear this boom boom, because it must go subsonic just before it lands. It's really incredible. And so I dragged him immediately to a launch and said, "You have got to see this." And he was blown away.
I have to admit, this is where I freely admit my age. I am old enough to certainly remember Gemini and the very first unmanned Apollo launches. And of course, I have to say I do blame Patrick Moore, James Burke, and Arthur C. Clarke, because if it wasn't for them, that was what got me into astronomy. That's what got me into spacecraft and everything. And of course, then I started reading the science fiction. And I'm looking forward to Dan Dare coming real, because I looked at his pictures of his proposed BFR. It's the Anastasia from Dan Dare. I swear, he's literally could be the Anastasia from Dan Dare. All it needs is a set of wings, and he's got it.
Well, I will be very happy if that rocket goes off. I am a little skeptical about it, because Elon seems to kind of go squirrel on you. He seems to sort of get a new idea and chases after that. But I mean, at NASA, we've been using his rockets for supply missions to the space station for a while now, and then that's why I've been attending them. The next big exoplanet mission tests launching in a couple of weeks, and it's going off on a SpaceX rocket. So we, at NASA, we've been using Elon's rockets for a lot. We're hoping the Falcon Heavy sometime soon, in the next year or two, will become human rated, safe enough to put people on, and then we can start launching astronauts from the United States again, which is what we really want to do. I want him to get that far, because at NASA we really need that badly now. And then I want him to later think about, the big rocket that might go to Mars. First, I want my human-rated Falcon Heavy first.
I think that would be brilliant. I don't know how the Orion team feel about perhaps a workaround so that a Orion variant could be mated to the Falcon Heavy. The European Space Agency has its own Soyuz launch facility, so I guess it's kind of a friendly race now. To see who can get man back up from the Western world.
Well, it's yes and no. It's because, this is something I think the public has a misconception about. And, the reality is actually better, I think, than what people think. So, right now, NASA plans to put our astronauts on a human-rated Falcon Heavy. And so, we don't see it as a competition. we really, really want the Falcon Heavy to be ready now. Because, our plans are to have these joint missions, with private commercial spaceflight and NASA. And everybody at NASA is looking forward to when we can launch from U.S. soil again. So, I think that, we've actually cleared space in our big vehicle assembly building in Florida. They're the big building that they used to build the Saturn V and the Shuttle in. We've cleared space in there for commercial spaceflight, people. We really aren't thinking of it so much as a competition. It's just, please give us a human-rated rocket now.
Yeah.
And whichever company does that and we can collaborate with, we're very happy. I mean, Elon Musk has been using NASA money to build the rockets that we buy these rockets.
Yeah.
He works with us, and we want them all to succeed. The more companies that succeed, whether it's Blue Origins or whether it's Sierra Nevada Corporation or Boeing or anybody, NASA's ready to work with any company that has those rockets.
I think we terminated the shuttle way too early. We should.
Well, yes and no. So, I definitely want something with the shuttle's capability. The thing that was difficult for us at NASA is that fleet was aging. They hadn't given us money to build new shuttles.
That was the pity.
And we were putting our friends on those.
Yeah.
So, the decision had to be made that these were probably not safe anymore. And if we weren't going to be allowed to build new shuttles, then you don't want to put your friends on things that you're not sure how safe they are. So I agree that I really wish we had the capability of the shuttle. But I'm also glad they made the call.
Yeah, I totally agree, Michelle. They did their job. They proved that spacecraft were reusable, and that I think is the important thing.
Have you guys been to the Atlantis that they have at Kennedy Space Center, the exhibit there?
Not yet. No, I'm in upstate New York.
No.
Yeah, well, if you have a chance, so I've been working at NASA for 20 years, and every time I go see that exhibit, I cry. It gets me every single damn time. It is so beautiful, and it is so dramatic to think what we did. And when you see this beautiful bird in front of you that's been, I forget exactly how many missions Atlantis had, but it's been around the Earth so many hundreds of thousands of times. It gets me every single time. I just can't believe how beautiful that was and what we accomplished.
I remember when we were doing. I used to work for a certain company, and we were doing some of the work on Giotto. That's taking everybody back a few years. And I remember that because of the fact that those of us who had been seconded to the Marconi group that were working on Giotto, we actually got to go into one of the conference rooms for Encounter with Hawley's Comet. And I tell you what, that was just sitting there in the boardroom at Marconi watching Giotto Encounter Hawley's Comet. That was just mind-blowing. And of course then we went on to Greg Skiller up as the second mission once we realized that there was still fuel and instruments working. Again, a mind-blowing. We weren't expecting the second mission when they turned around and says, hey, we can do a second mission now. We have fuel, we have instruments still, everything worked beautifully. I know the camera got damaged at Hawley Encounter, but hey, there's other things we can do, and we did it. And I think that just shows how inventive we are as a species.
Yes.
A lot of people thought that the probe was finished. The Vega probes did a flyby, and that was it. Giotto penetrated the coma to get as close as it could to the nucleus to image. And of course, the camera's been hit, but we got the image before it was hit. And then we went on to a second mission. And I think this is perhaps a way we can go forward. I know that it's been done with New Horizons. I know that the mission in the asteroid belt, they had 2 targets, and they've gone to 2 targets. But I think this is perhaps a really good thing to do. Have a main mission, and if your space probe is still A-OK afterwards, go on to a secondary mission, because you're getting even more science for your dollar that way.
Well, absolutely. Like you mentioned, one of the things I'm looking forward to most in the next year coming up, I guess a little more than a year, is the arrival of New Horizons at this Kuiper Belt object. Because, as you mentioned, New Horizons went past Pluto, and that was the goal. That was all that the spacecraft was designed to do. And then, like you said, it was still working, and it was careening into the outer solar system at super high velocities. And we realized we could aim it toward, a couple different of these mysterious Kuiper Belt objects. This is the first time we will ever explore this part of the solar system. So it's going to be January 1st, 2019, when we do the flyby of the Kuiper Belt object. We know it's sort of dumbbell shaped, almost like the Comet 67 GP. We actually know it's kind of reddened. It probably has kind of an organic reddening to it. And I am really looking forward to seeing what a bit of the Kuiper Belt looks like. We've never seen. And you mentioned the asteroid mission. So yeah, we had a mission that's still running called Dawn. And Dawn mapped the huge asteroid Vesta, and then continued out to the largest of the asteroids, Ceres. And this is, the huge advantage of having these ion propulsion, these electric propulsion engines that, unlike a traditional rocket that blasts you to a high velocity but then shuts off because it's out of fuel, you turn on one of these electric propulsion ion engines and you can keep it on for decades. And so we actually wondered at NASA whether we should leave Ceres and actually go on to another asteroid. But Ceres turned out to be so fascinating, they actually decided to spend the remainder of the lifetime of the mission observing Ceres. Because on Ceres, we actually have found evidence of cryovolcanism, volcanoes pushing ice out, and really interesting chemistry that might even suggest there's liquid water under the surface. And this is blowing our minds because Ceres is a small body. It's only it's like 800 kilometers across. And it's not in any kind of tidal warming relationship like the moons of Jupiter or Saturn. So we don't know how Ceres is staying warm inside and how there could still be liquid water in there. So we may have missed something big about the way that terrestrial planets work. There's surprises out there still. And so, yeah, these missions that have multiple uses and even keep going have made some startling discoveries.
What was your first comet that you saw?
Okay, that's interesting. Let's see. What was the first comet that I actually saw? The thing is, I actually had really bad luck with Hale-Bopp because I used to live in Australia, and I was living in Australia when it was in the northern sky, and then I was in the north when it was in the Australian sky, so I completely missed Hale-Bopp. My husband and I go out with binoculars. I mean, very much like as you began the show, you were sort of seeing, what's in the sky tonight. And if it's something that's reasonably easy to see with binoculars, we'll go out and try to find it. And I love it. I love seeing that smudge in the sky, which is, the gas around one of these beautiful floating mountains, these ice and rock mountains from the early solar system. But the interesting thing is I don't remember the names. We just get the coordinates. We go out, we look up. And to me, I still tell people how magical it is just to go out and look at the night sky. Mm-hmm. You don't even need a telescope or binoculars. I obviously love using telescopes. But go out and look at the moon, go out and look at the constellations. It's still exciting to me to see a little named and numbered smudge that I don't remember the name, but it's a little bit of the early solar system. And I think that's so damn cool.
Now, we have a question that we ask all our guests. If you had an unlimited blank check, what comet would you want to visit for a science mission?
It has to be a comet that I go to?
Okay, we'll do it as a multiple target mission. How about that?
Oh, yeah. Well, I mean, this is actually, it's funny. I'm an astrophysicist, so this is not my specialty, but I really, really think we're quite close to discovering that some of these moons in the outer solar system are habitable. I mean, if you want to call them really, really big comets, things like Europa and Enceladus, these icy moons that we know have liquid water under their surface. It's Enceladus. In Enceladus's case, there's water flying out through cracks in the ice, and we're so close historically to being able to say that there's life out there. I mean, even if it's just microbial life, I'll take it. I'll take an extraterrestrial microbe. I would love to go to the Smithsonian someday after a sample return mission and look into this, leaded isolated tank under a microscope and actually see a microbe from somewhere other than the Earth. And to me, I think they exist. We just have to prove it. We have to find them, and we have to get out there and do sample returns. So, I mean, my blank check is, oh, God, I think we're close. I think we're very close to finding microbial life somewhere else.
This has been a wonderful interview. I'm actually out of things to ask because we can't do a normal 10 questions, can we? Can we do what about 10 questions?
Go for it.
10 questions.
Do you or have you ever listened to music whilst observing the sky?
I mean, you have to because you're trying to stay awake. I mean, when it's your job to be at a telescope at night, there's always music playing because you tend to eat too much. Like I always bring a whole packet of like Thin Mint cookies or Tim Tams, and you're trying to keep yourself awake and alert. And I'm usually dancing around the observatory, just trying to keep my heart rate up. So I listen to music all the time when I'm observing. It tends not to be very ethereal, relaxing music because I'm trying to keep myself awake. So it's a bit on the kind of 80s new wave. That's embarrassing. Yeah.
That's okay. I still listen to Kate Bush and Toyah, and
there you go. Yes.
I will even put my hand up and say I still listen to Duran Duran.
Yeah, well, I mean that's the sort of stuff from my youth, and it keeps me awake at night. So, when you think about all these astronomers up all over the night, all over the world, up all night, yeah, we're just trying to stay awake. We're dancing. We're all dancing.
I have to try that when I get the. I'm buying a new telescope at the end of this year, and I've decided to go for broke. I'm buying a 0.5-meter Dob. So this is going to get interesting. Just see the neighbours watching me dance around it whilst I'm imaging.
That'd be interesting.
I think I was on a NOVA program one time. It was called The Secret Life of Scientists, and one of the things I talked about is it was called Dancing with the Stars, haha. But the idea was that I've danced at observatories all over the world, and I usually bring some sort of offering to the mountain too. Like in Hawaii, the telescopes are at they're the summit that was sacred to the goddess Poliahu, and so I usually bring Poliahu like a big bottle of rum that I'll pour out and ask for good skies and permission to be on the mountain and all those things. I mean, I know that's sort of a strange, superstitious thing to do, and I'm sure some people would be insulted and say that's cultural appropriation. I apologize for that, but I always feel wherever I go, I have to bring a little something for the mountain.
I disagree. I think that's showing respect for local traditions.
Definitely.
Well, I mean, as you know, it's contentious, and that's always hard. I guess the next high observatory I'll get to next year is ALMA, and that's the Atacama Large Millimeter Array, which is in the Atacama Desert in Chile. And it's spectacular. It's at 17,000 feet, and that's the highest I've ever been. And I do okay. Usually after about 10 minutes of just sitting still and relaxing when I get up there. I'm okay to walk around and do some work. And it's the sky looks like something from another planet.
Yeah. Because
you're down in the south where the center of the Milky Way is higher in the sky than it is in the north. And you see much more of that thick disk of stars around the Milky Way than you do in the north. And it just doesn't look like our sky at all. It looks like you are in some science fiction scenario, 17,000 feet on top of the Atacama Desert, looking up into another planet's sky. If you ever have a chance, get yourself there.
I took a friend insisted that I went with them to Kielder in the north of England many years ago. Now, Kielder is an official dark sky preserve now, but back then the campsite does not have artificial lighting. So basically, you've got tents, you've got a couple of trailer homes you can rent, and it's dark. And I remember coming out of the camper I was in, and just looking up, and there was just so many stars. You couldn't work out the constellations. It was that dark.
It's unusual, Nick. It normally rains there.
Well, as I say, it was just it was a nice. I'd say it was late summer, maybe beginning of autumn, and it was just right. And you just walked out. You got out of your accommodation. I'm just sitting there. I'd been to the local ceilidh earlier in the evening, and just sitting there, just staring up at this really star-studded sky. There was just so many stars you could see. I suppose when you live in an urban area, you look up, you can make out Orion, you can make out Ursa Major and Minor, Cassiopeia. But here it was that dark that you just were just awestruck. It is like speaking to some of my friends down in the southern hemisphere, particularly in the Swan Hill group in Australia. There's like you're talking about looking up at the Emu in the sky, at the Greater and Lesser Magellanics, it was kind of like that.
It's really something. I think that a lot of people who live in the Northern Hemisphere don't realize how much of a change it is in the southern sky. I mean, it's like I said, it's just, there's more of the Milky Way visible, just because of the way the Earth's orbit is angled around the sun. And it's a brighter sky. It's a more colorful sky. Of course, you have the Magellanic Clouds, which the first time I saw them, I thought were clouds, hanging up there in the sky, until you realize that they're satellite galaxies.
Yeah.
And, I really recommend to people, I mean, anybody who loves astronomy or might count themselves an amateur astronomer, please get yourself to a southern sky, dark sky location. And the best I've ever seen is Chile. I think that, if you want to take a vacation to Chile, that is the driest place in the world, the Atacama Desert, and the sky will just blow you away. I actually, somebody pointed out to me that night when I was at Alma that I was casting a little bit of a shadow, and it was a moonless night.
Yeah.
And we realized from the angle of the shadow that it was a Milky Way shadow. Wow. That the Milky Way itself was so bright, it was casting a slightly dim but noticeable shadow.
I image online quite often out of Siding Springs, and
oh yes, yeah,
just seeing the sky there.
I've had the honor of actually using the telescopes at Siding Springs, and yeah, that was amazing. And then I almost got run over by a kangaroo checking the weather. I went out to go see where the clouds were coming from, and we surprised each other and both ran in the opposite direction. So I have lots of Australia. I did most of my dissertation research on Australian telescopes, and I just fell in love with the place.
On the bucket list, I guess.
Yeah, absolutely. I better get on with my day. I'm talking to you guys.
Michelle, it's been great to have you on the show, and it's great to have you back on Astronomy.FM, because I think the last time we had you on, it was for the Event Horizon with myself and Marty. That was a fair while ago.
Yeah. Well, good to be back.
Yeah. So, Michelle, thank you very much for coming. Great to have you.
Thank you, yes.
And
I will enjoy listening to your show. Like I said, I was very inspired by the beginning and just thinking about all the things you can see in the night sky, even tonight.
Well, we get a bit of flack about it because some people say we should put the really nice bit, which they consider the interviews, first, and then do the boring bit, which is the shipping forecast. But I disagree, because in a lot of respects, I feel the shipping forecast sets up the show, really.
It does.
You just need that really lovely British voice to do shipping forecasts. I mean, you have to. So
Absolutely.
Yeah. We have to get somebody posh. We'll have to get somebody posh.
Well, we just need to practice our Lord Reith BBC. This is the BBC.
Watch the Pathé News from 1937.
Yes.
Yes, absolutely. Shall we do that?
Yeah, we can practice that. We're up at the hour, so great to hear from you, Michelle. Thank you for coming on.
Good night from me.
Good night. Thank you for having me.
And it's good night from us too. Good night, everyone. We'll see you next month.
We hope that you've enjoyed this program from AFM Radio, the broadcast service of Astronomy.FM. This program has been released under Creative Commons license. Please contact us for details. You may find more of our AFM original programs on our website. It's really easy to find us. We are Astronomy.FM. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is Astronomy.FM Radio.
Hi, this is Tavi Greiner, Astronomy.FM's Vice President of Communications. If you enjoy our programming, please let us know with a donation to Astronomy.FM/donate. We really do rely on your support, and it's true, every little bit counts.
AFM